Okay, we got a lot of interesting answers to this question, many of them right, but not all. Okay, because there are probably more mistakes than there were right answers. So from the flow model, now if we do our dy dt in this form, which is just like it was earlier, except I've got units here now, centimeters to the 1/2 over seconds, right? Well, now, if y is 16 centimeters, then when I plug this in here, the units will work out to what they should. And we see, okay, so we get dy dt equals -0.04 centimeters to the 1/2 over seconds. And we can do that times the square root of 16 centimeters. Well, that's -0.04 centimeters to the 1/2 per second times square root of 4 times the square root of centimeter. I mean, a centimeter is part of y, right? Mm-hmm. And you're taking the square root of y, so you can't just slap a centimeter on at the end here, okay? If you do that, you're doing algebra by what it looks like rather than by what it is. Yeah?
Why did you put the square root of 4 there?
Because I was hoping somebody would notice, because you gotta keep an eye on me. Okay, thank you. Right? You know, I'm getting one step ahead of myself, just like, you know, a lot of people just wanted to slap that centimeter on there. Okay? I'm just thinking one step ahead, late in the afternoon. I'm 100 years old, you know, all that stuff. -0.04 centimeters to the 1/2 per second hasn't changed yet. Square root of 16 is 4. And the square root of centimeters, of course, can be written as centimeters to the 1/2, right? Okay? So now we can multiply the 4 by the 0.04, -0.16. It's going to be centimeters to the 1/2 times centimeters to the 1/2 divided by seconds. Now, by the laws of exponents, a 1/2 power times a 1/2 power, the same thing as the, well, I'll write it out, -0.16 centimeters to the 1/2 plus 1/2 per second, which is -0.16 centimeters to the 1 per second, which is just -0.16 centimeters per second. So you see that when on problem 16 I give it to you in this form, all the units work out. Okay? And the units are just algebraic quantities. They have meaning, and you want to pay attention to that meaning so you know what things mean, and you know if the units don't work out, either that things don't mean what you thought they would, or somebody screwed up when they posed the problem, which is possible. Okay? Or you screwed something up, or you don't understand what's going on. Okay? Lots of messages that you get from looking at the units and thinking about what they mean. Extremely important. One of the biggest habits I've got to get physics students out of is writing numbers down without units. And our engineering instructor says the same thing. Okay? It leads to all kinds of errors. You always want to write down the units when you're working in units, when you're in that context. Now earlier I said, okay, this is going to be in centimeters per second when y is in centimeters. Now I didn't have these things on there, and it was to be understood that whatever y was had better be in centimeters, and that your result was going to be in centimeters per second. Here, this form tells you that that's what you're going to get if you put in y in centimeters. It also tells you that if y is in millimeters, you probably want to change it to centimeters so it'll articulate with the centimeter here, right? Okay, very important.